Let's begin. Today is June 5th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards with its 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the 6 criteria cards of 3, 6, 9, 12, 20, and 22, and uses the green verification cards. And above you'll find the unique identifier for this puzzle today that you can always go on turingmachine.info to search and get more details. Let's solve. So in a grid we've got our 6 criteria cards. On the top row we've got criteria card A, criteria card B, and criteria card C. And the bottom row we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at the middle digit, the square digit, and compares that value to the number 3. So should the square value be less than 3, equal to 3, or should it be greater than 3? Criteria card B again looks at that middle digit and will let us know whether that value is an even or an odd quantity. Criteria card C looks at the 3 digits in our code and will let us know how many of those should be 3. Are there no 3s? Is there 1, 2, or possibly all 3 of them are the digit 3? Criteria card D will look at the triangle and the circle values, the first and the last, and compare them. So should the value of the triangle be less than circle? Should they be equal, or should triangle be greater than circle? Criteria card E again looks at the 3 digits and will let us know a little bit about how they're structured, specifically whether there are no repetitions, meaning that all 3 digits are unique, as in the example 125. Could it be that there's a double or a repeating digit, as in the example 112, or potentially a triple number, meaning it's a single digit repeated 3 times? And finally, criteria card F again looks at those 3 digits and will let us know something about their ordering. Are they slowly increasing, or rather, are they ascending or in ascending order, as in the example 135? Are they descending, slowly getting smaller, as in the example 421? Or potentially they could have no order, as in the example 231. Now it's no order because if you notice it goes from 2 to 3, so it increases, but then it comes back down to 1. So that fluctuation is what really defines it to have no order. And remember, our objective is to find this unique 3-digit code that abides by the criteria cards that we've just described. And we're going to start off with our proposal of 314. So the first thing I want to do is I want to find out if that middle digit is an even quantity or an odd quantity. So I'm going to test criteria card B. Okay, so the Turing machine responds that it does not agree with my proposal, or basically my value for square. Notice that I have an odd 1 in my square, but the Turing machine does not agree with that. So that means that it must be an even quantity. So that's what I'm going to write down in my notes in section B, that square is an even, I'll just say digit. Okay, and so basically I'll just cross out all of the odds, since that's what the Turing machine disapproved of. Okay, and so we could figure out whether it's a 2 or a 4 using criteria card A, but I think for the moment I'm going to look at other options. So actually I'm looking at criteria card E, and I want to know if all the digits are unique, is there a double, etc. So let me go ahead and test criteria card E. Okay, so the Turing machine approves of my proposal. Notice that my values are 3, 1, 4. They are all distinct. They have no repetition. So that's what I'm going to write down in my notes for section E, that there are no repetitions. So basically that means that, again, they're all unique. So at best, I already know I have an even in square. If I happen to have another even, it would have to be, well, either 2 or 4, since I'm speculating that there could be 2 evens. Let's see, what else? We do have this criteria card that tests for the quantity of 3s. So obviously we know that there can't be 3 of them, since we do know there is an even. So there's either 2, 1, or none. Or we can also query the comparison between triangle and circle. So I think at this point, I think I'd like this criteria card D a little bit better, just to kind of get an idea of what triangle and circle might be. So let's go ahead and test criteria card D. Okay, so the Turing Machine also approves of my proposal. Notice that in my proposal I've got a 3 for triangle and a 4 for circle. So it approves that triangle should be less than circle. So let me go ahead and write that down in my notes. And that was criteria card D. So we're going to say that triangle is less than circle. And let's see what that might say about our values. So if triangle is to be less than circle, that means that triangle cannot be a 5. 5 would be too big for triangle, since there's nothing bigger than that, which circle should be. And similarly, circle can't be 1, because then there's nothing smaller. Okay, well, that does it for our 3 Turing tests for this turn. So we're going into thinking through what a good second proposal might be. And so again, we did not test A, but that's a 50-50. We know what that'll be. And the question is, notice that how many 3s? Again, at most there's going to be 2, as displayed here. We have not crossed out these 3s for triangle and circle, so there could be 2, there could be 1, or potentially none. And we do have this uniqueness, and then there's the ordering. Well, I really don't have a good feel for what the overall structure of the solution will be. So let's get the square kind of settled. What do we want to look for? So it could be that, let's see, how can we determine what triangle and circle might be as far as odds and evens? Because I mean, it's pretty wide open. Could there be 2 3s and it's like 3 2 3 or 3 4 3? Ah, okay, never mind. No, so it can't be. Okay, so I'm glad I said that, because obviously they can't both be 3s, because we've already established a triangle has to be less than circle. So that means that either there is a 3 or there isn't. There's no way for there to be 2 of them. So it's either there or not. And if it's not, if there are no 3s, just imagine all the 3s being canceled. Boy, that sure does leave a lot of 2s and 4s, and then the 1 and the 5. That would be an interesting scenario where, what if there were no 3s? Could somehow triangle become 1 and circle be 5? All we know is that it's got to be less. And there's just too many possibilities. And then there's the ordering. So let's see, what if there were no 3s? What could we do? If there are no 3s and they have to be unique, I've got 1, 2, 4, and 5 to pick from. And square, we'll know what square is. So I wonder if it could be somehow like ascending 1, 2, but then there's still 2 possibilities for 4 and 5. Yeah, there really is no sort of indication. What if square were 4? What could triangle be? How could we force it to be something? Yeah, how would you restrict triangle to be a single value? Wow, this is very interesting. If there are no 3s, then we're left with 1, 2, 4, and 5. Square could be determined to be something. If it's 2. Okay, so what if square were 2 and there's no 3s? Then that means that would limit circle to be 4 or 5. And since if it's 2, how could you make circle be 4 or 5? I guess by definition ascending, if it was ascending, it could be 4 or 5. Yeah, but then how would you distinguish? Wow. Or maybe if square is 4 and it's ascending, then that would force circle to be 5. And then maybe there is a 3. Okay, so I want to try 3, 4, 5. There's just too many possibilities, so we'll have to try something. Okay, so let's see, what's the first thing we could do? Do I want to figure out what square is definitively? So I think if I do, if fortune is on our side and square is 4 and there's a 3, and that would force that to be 5 because of the triangle being less than. Yeah, let's go ahead and do criteria card A. Okay, so it is definitely a 4. Notice that since my 4 is greater than 3 and we only have evens, that would mean that it has to be the 4. But let me go ahead and put in my notes that square is in fact greater than 3. So square is greater than 3. So that means that square cannot be a 2. Okay, so far so good. And if there is a 3, but it doesn't say. Oh, this will be interesting. If there is a 3, where does it go? I was thinking triangle, but it could easily be circle. But it couldn't be circle, because then how would you distinguish between 1 and 2? Yeah, I would almost have to go to triangle. So let's go ahead and test criteria card C. There is no 3. Okay. Well, I should say there's no single 3, but at the same time they both can't be 3. So again, we know that there can't be 3 3s, there can't be 2 3s, and it's saying that it's not a 3. So that means that there is no 3. I'm going to deduce that there are no 3's. So I'm going to deduce there are no 3's. Okay, so I'm going to cancel both of them. Okay, so there are no 3's, and we do have a 4. Okay, so, wow, I'm still, okay. Well, there's really only one thing that we can test, and that's criteria card F. All right, let's go ahead. Okay, so it's definitely not ascending. So the question is, could it be descending? I can't see it being descending because they have to be unique. If this is 4, there's nothing larger than 4, so it's not descending. So again, in my notes, I'm gonna deduce that there's no order. Okay, so if there is no order, that means that triangle has to be 1 or 2, since square is 4, and then it would have to, and that forces a circle to be 2. And because it's got to be unique, it would have to be 1, 4, 2. Wow, that is a very interesting way to get the solution of 1, 4, 2. Okay, so let me just put the 1, 4, 2 here so I don't forget. Okay, so let's go back and kind of review. Since I do know square is 4, and it's not ascending as I had, it has to have no order. So it can't go, it can't be 5, and because it's a unique, it can't be a 4. So that's why circle is neither 4 nor 5. Okay, so that gives us our 4, 2. And again, because of uniqueness, that would mean that triangle can't be 4. And again, because of uniqueness, triangle cannot be 2. Wow. What a very interesting puzzle. I really enjoyed this. Okay, well, we're not out of the woods. I still have to test, but it looks like based on all the notes and everything we've discussed, I feel confident about 1, 4, 2. So let's go ahead and verify. We got 1, 4, 2. Verify, fantastic. But again, we have to go and test the Turing machine to see how we did. And so let's go back and see, what did we test? Okay, so we tested one of each, and we did BDE first, and the last 2 were correct. And then in the second turn, we did the remaining, and A was correct. So it's ADE, sorry, BDE, sorry, BDE. So B was wrong, but D and E were correct. And then A was correct, and then the remaining were incorrect. So C and F were incorrect. So how do we do? Okay, we tied. So I knew that, you know, as long as we did the number of criteria cards, that we'd at least have a good chance of beating the machine. We beat it just because we tied. But I have to say, what an interesting puzzle. How everything at the very end I mean, there was still a lot of digits left over, but kind of having to go back through each of the criteria, we had to kind of do like almost not a double take, but go back and further refine and see what else we could eliminate. But what an interesting puzzle. I have to say that's got to be one of, if you could have a favorite, just because of the subtlety, it was a very enjoyable solve. Okay, well that does it for today. If you did see something throughout the video that you'd like to comment, please do share. If you like the video, give it a thumbs up. And if you don't want to miss any future videos, make sure to hit subscribe to be notified. Well, thank you so much. I really enjoyed this. I hope you did as well. And until next time, have a good one.